So let me introduce Michał.
Hi guys.
And I'm Dominik. We are from XTRF, the company that deliver the best translation management system ever. Michał.
Right, guys. So the purpose of this talk is going to be to share some experience we had while implementing our infrastructure for hosting this XTRF applications, our product. I mean, you will find a lot of let's say common problems that you can face while building such thing for any other Java enterprise application, right? So we're going to show you some success and failures we had when building this infrastructure, and give you some useful hints. Maybe you'll find something useful. Right. So maybe let's start from our product itself. So just so you can have a better understanding of what we do, what kind of product we are dealing.
Yeah, that's really important for you to know what kind of challenge we had. So basically, XTRF is a platform for management. We manage very specific area of translation. We deliver our system to translation offices, localization departments all over the world. We have more than 250 customers all around the world in more than 40 different countries. This application grew from the very small one, JBoss application, to quite huge one, well, JBoss dependent. And the growth of the application enable us to deliver more and more features to our customers. So basically, we're kind of ERP system with all the customer management module, vendor management module, project management module, invoicing, CRM, business intelligence, and so on. So it's quite a rich platform in terms of functionality. We also empower lots of UX work in our system. So basically what you can see here on the next slides, it's a new version of our system with a new graphic user interface. So next to the all the experience that we'll be giving here today, we also faced the transition period from a Hibernate stack and JSFs to the modern infrastructure based on RestAPI and AngularJS. It's probably a subject for the other talk. Anyhow, we have XTRF platform, which is J2EE application or JEE application, quite heavy, with quite significant requirements in terms of memory, CPU consumption, all the services that you need to for the application to run smoothly. Basically, it involves, of course, the customer interaction with the application, but also interaction with customers of our customers and vendors of our customers. So we deliver the platform for our customer to interact with their partners. So the requirements are here. Of course, they are different for different customers. For a smaller one, probably they are a little bit less. For a bigger installation with 50 or 100 customers, users, they're a little bit higher. But you can get the feeling of what the size of application we are talking about. And of course, having one customer probably is not a big challenge to deliver such an infrastructure. But when you grow, it becomes a real problem.
Okay, so let me carry on from that point. So if you're here, you're probably into infrastructure, right? You're just as admin, or you already have some experience in building infrastructure.
Or you are aware, or you are experienced Java developer that is aware that it's not only about the code, but also how to run the code in a stable environment, which is kind of challenge today.
Right, but if it comes to business features, right, business value, you are sure it's there, right? So it means you'll get paid at the end of the month. That's cool. You care about footprint. You care about things that you're required to do in order to build a proper infrastructure to make this application run smoothly and efficiently. As Dominik said, it's Java enterprise applications, right? So there are so many nice talks about microservices nowadays, even today. But if you think Java enterprise, Micro is not the very first word that will appear in your head, right? Forget it, right? If you have some Java experience, most likely you think about big applications that run inside application servers that consume a lot of memory. It takes time to boot them up, shut them down. So these are kind of problems we are dealing on a daily basis while developing Java applications, right? So building infrastructure for this kind of software is not going to be an easy task. Right.
I think that what is really important to stress that we're aware that it's not the most coolest application infrastructure architecture today, but the cost of rewriting the entire application is extremely high. So I think that it's something that we challenge today in many other companies, that we have inherited code, that we had something that already runs quite smoothly, and we need to provide infrastructure for these systems without any real possibility to rewrite the entire application. And I guess that there are lots of persons in such a situation.
So let's go one by one how it goes. You have a single customer, right? You need to expose your application to deliver business value. What do? You basically either buy a virtual machine or buy bare metal. You put your JVM, your application server, JBoss application server in our case, install database, do some configuration, maybe tuning, and basically that's it, right? Maybe you need to make a choice what kind of operating system the application will be running on, whether it's going to be your environment or you want to set it up on customer side to build an on-premise installation. And then in lifecycle of a very single system I had a chance to work with, there comes this really awkward moment, right? You get successful. I mean, it means you have more customers, right? That's may or may not happen. And then if you're experienced, you approach your CTO, or to make matter a little bit worse, CFO, and try to convince him or them that it makes sense to refactor your applications toward multi-tenant architecture, because it's a good thing to do, right? And in ideal world, you would receive a response like this. Okay, Michał, take your time, take as many resources as you like. As we understand, that's very crucial that multi-tenant architecture is important for the infrastructure to be utilized efficiently. Having said that, though, reality is slightly different, right?
Okay, I'm the CTO. I said no.
That's his fault.
You cannot rewrite the application. You have to think about something that is cheaper. It's even not about money at the end of the day. It's about time, because I need this infrastructure to scale up like in weeks, not in years when the rewritten application will be finally delivered.
Yeah, so the response would be expressed like this: over my dead body, right? You need to set up yet another applications, and I want it to be up and running by the end of the day. So what do? You proliferate, right? If you have capacity, you add more JVMs within a single node. You set up more application servers, set up more JBoss. Surely, soon you realize it's not enough. You need to add more worker servers, more worker nodes. And there are several issues you have to solve on that journey, right? To isolate processes, make sure that port numbers don't collide against each other. Most likely, if you're not masochist, you try to automate your work a little bit, right? You most likely invest your time and energy into automation tools. For instance, Chef Puppet, you want to make sure that availability is higher, like you may invest your time in Pacemaker, like we did. You may as well write your own script for automation, and most likely you will end up with a layout like you can see here on the slide, right? There are multiple nodes, several database servers, either for the sake of replication or for data partitioning. You need to route traffic from your customer over proxy server to proper JVM process. Most likely you will span some sort of a distributed file system across all nodes, just to make sure that the storage access is unified, right? These are all activities you have to undertake in order to build infrastructure like this.
So and then when you finally is successful, I mean you have your first 50 or 100 nodes, your CTO comes and said, Michał, we would like to install trial. I need 200 more demo instances. Where can I have it?
Yeah, right. So the problem is you get successful one more time, and you need to deploy more servers. Our experience is that this kind of layout, this kind of cluster environment can hold up to, let's say, 100, 120 JVMs, which is a lot. It's not some sort of a technical limit, but let's say common sense. Later on, it's getting difficult. So your goal is to build an infrastructure that can host more JVMs. What do you do? So either you proliferate one more time, so you start, let's say, building yet another cluster and invest your time in building a software that will help you automate some actions on clusters, or you seek for other solutions. Everyone has heard about cloud computing, right? There are so many, cloud providers. They have so many nice services. So you take it under consideration and try to explore it a little bit more.
Yeah. In the meantime, CFO came and said, no, it's like we're paying few $1,000s for all this infrastructure. Why can't we go to cloud? They are claiming that they are very cheap. It's like few bucks for a month. So let's definitely go into the cloud.
Right. So before we do so, let's just list down pros and cons of the infrastructure we had just seen. Right. So the price is crucial. So if we fill up this cluster environment, this 120 JVMs for instance, we are able to get to the price around $13. But please don't tell this number to our customers, right? They won't get it, right? Just for you. So it's a pretty low cost for a process that can consume up to 6 gigabytes of memory. There are several advantages, though. You have direct access over your cluster, right? You can change operating system parameters, tune your database. So we have direct control over your infrastructure, which is good. Whereas in cloud you don't have it, right? By definition. There are also other, let's say, obstacles in the cloud environment. This is something you don't control. Whereas in a cluster environment, in your own infrastructure, you can decide what kind of communication between nodes will you have, right? Most likely it's the same local network, so things like spanning single distributed file system will work. Whereas in cloud, it's kind of, let's say, different.
And then your CEO came and asked, what would happen if our favorite data center, by the way, while using Hetzner, what will happen if its data center would collapse? So, okay, we would have a serious problem. And the more successful you are, the more this answer is not acceptable. So definitely running this infrastructure in one data center, it's not secure enough. But the infrastructure, the architecture we just proposed, is not able to handle different data centers. So basically, we need something different.
Right. So direction is cloud. Let's go cloud, right? So there are certain questions you need to ask yourself before you can benefit from this kind of infrastructure. It's not a recipe. Actually, we invented this list once we failed, right? So this is why we share this with you.
You don't have to repeat our fails.
Yeah, you can be smarter than us. That makes sense. And so first thing you should think of is about all depending infrastructure services, like for instance database. What kind of database do you depend on, right? Does the cloud provider gives you this opportunity to benefit from the, say, SQL service? Is it there? Most likely you will rely on local file system. So the question is, how do you actually use this file system? Is it like you put just files and binary content and read it from time to time during every single, let's say, HTTP request? Or maybe you do something different. In our case, it was very important to understand that our system relies on directories, very sophisticated directory structure. This usage pattern is kind of important if you interact with cloud services rather than local file system. Then, as Dominik said, can you afford refactoring? Can you actually change the code? If the code base is huge, your let's say 200, 300 customers already rely on a product. Can you actually afford refactoring? Can you change anything? Right? Most likely, cost will kill you. Right? So that's kind of important. Now, pricing. If you have a clustered environment, the invoice at the end of the month is kind of simple. You have, let's say, 20 position, listing out your server. That's simple. You pay. You know how much you will pay. Whereas if it comes to cloud infrastructure, it's getting much more sophisticated, right? Each service is built differently. You have to go through this billing scheme to understand it, right? I suggest you open Amazon, for instance, Amazon pricing calculator. It's not that simple actually to figure out how much does it cost.
And it gets complicated if you count that your 200 more customers behave a little differently. So we need to predict their behavior and the influence of these actions on your final billing.
Yeah, it's forecasting also important. So you decided to give it a try, right? We have tried with Amazon and several other providers, and soon you realize that there are a lot of interesting services you would love to benefit from. You have a look at the services, you have a look at the application. At the services again, have a look at the application, right? You burst into tears, right? It will not be that easy. So first thing you have to start from is to understand how this core cloud service works that will let you host your application, right? We have JVM and let's say Postgresql database. This is what we start from. And there you go, right? Every single cloud service gives you that possibility to get a virtual machine. Most likely the solution is based on any virtualization technology. You can basically set up as many VMs as you like, right? It depends on the capacity of credit card holder. And that's kind of simple. Having said that though, the pricing is totally different, right? You pay not for the entire month up front, but usually you pay for CPU hour you have just utilized. Well, that sounds great, but the question is, can our application benefit from that feature? It's legacy code, right? You won't be able to shut it down while the customer is not looking, right? It has to be available all the time. So sounds nice, but you won't be able to benefit. If it comes to other services, that's slightly different. It looks like the conclusion is that they have different billing scheme, right? You pay either for a number of messages sent over some message-oriented middleware, for instance, or number of gigabytes store. That's let's say more attractive, right? Because you won't waste your resources. However, it's not that obvious whether you can change your application to benefit from the services. So let me get back to it in the next slide, right? So let's have a look how much does it cost to host JVM like we have, right? So we need to find out a virtual machine that will let's say contain application server like JBoss that can consume up to 6 gigabytes of RAM. We need maybe a Postgresql database, a little bit resources for operating system, obviously, and these are the prices that you can find in catalogs.
Yeah. It's the moment when your CFO gets heart attack. You cannot say that on the bare metal we paid like 30 zloty per one instance, and now we need to pay like $100 or more for one instance to operate for the entire month. It's extremely expensive. And it is something that no cloud operator will tell you.
Yeah, so it turned out to be clear for us that we need to build something different. Maybe we can benefit from those cloud services we like, that are technically more or less in sync with our ideas. However, this cloud computing infrastructure needs to be rebuilt, needs to be replaced with something different that we can possibly afford. So that's price is one thing. And then we realized that there are several key assumptions we have to go through before we can carry on building such infrastructure. We realized that we need to be vendor agnostic, right? There are so many cloud providers. Of course, we don't want to get ready for a collapse of a single cloud provider. That would be ridiculous. But pricing model can change, right? This is something you have to be prepared. If you're using DigitalOcean today, your usage pattern of application may change because some new features will turn up, and then you have to switch, let's say, to different providers. So this is something you have to keep in mind, right? To build your infrastructure that you can, let's say, more or less easily switch from one cloud provider to different one.
And our experience with maybe I won't name this cloud provider, is that they are unable to provide the infrastructure on time. So imagine that you ask them for 20 new virtual machines and they give you only 10 and say the next 10 will be available next week. It's not the contract we had in mind by calling a service an instant cloud.
Mm-hmm. Okay, let's move on. So what we did was basically to identify these cloud services that we could possibly benefit from, like storage, database services, maybe SMTP, like mail services, and we start building this computing tier on our own experience. We of course wanted to sort out those issues we were facing while dealing with this initial, let's say, cluster environment. We needed better isolation and so on and so forth. So then Docker appeared. Really useful piece of technology that we tried to benefit from. So yeah, that's a kind of, let's say, base software that the entire infrastructure was built on. However, Docker forces you to follow certain pattern, right? You need to put every single application in containers. You need to make sure that containers are lightweight, more or less, right? There is no state in the container itself, right? You want to get rid of the state from the process. So that's something totally different than we used to have, right? You need to make sure that the worker knows it's basically immutable. So if it's gone, you can set up yet another one, different place, without losing state, right? So the assumption was that state should be kept in those cloud services, like global storage, global database, for the sake of further use, right? So this is more or less the technology stack we have started from. So if you are into Docker, into this kind of technologies, you should already see that this is pretty outdated, right? I mean, that was a year ago, a year and a half, more or less. The landscape of technology changes. And so we decided to build our infrastructure on Docker, on Fig, which is now also later on replaced by Docker Composer. etcd, really cool piece of technology. I'll give you some more information about this later on. Conv also go in sync some proxy services. These are, let's say, toys you need to use in order to build a, let's say, computing infrastructure. So our goal was to build infrastructure that can hold, let's say, up to 1,000 containers. Our prior limit was around 100, 120 JVM in, let's say, single infrastructure. Here we wanted to get something bigger. Of course, we want to keep the state in global services, so we don't want to rely much on, let's say, single data centers. We want to be tied to a single geographic location. So it's doable if you keep your state globally, right? Someone else will simply take care of exposing this state to you if you want to let's say, boot or start containers in, let's say, Middle East or somewhere. As an exercise, I suggest you need to find out how much would it cost to set up, let's say, few servers in Qatar, for instance, just by curiosity. Okay, so this is what we wanted to do, right? But there were several problems on our way. First, and probably most difficult one to solve, was storage. I'm pretty sure that most of you are familiar with Amazon S3 service. Pretty nice idea. It's key value store with infinite space. Actually, the size of binary data that you've put in doesn't matter. However, actually, it's not a file system, right? It's a storage service. So if you want to use it, you need to benefit from certain SDK, right? There are so many nice binding for every single language. But again, then we get back to this situation when we have to change something in the code, something we don't want.
No, we cannot, actually, because some of our customers are using our application their own infrastructure, so we cannot force them to switch to S3.
Yeah, precisely, right? So also kind of important for the customer. Okay, please tell me where my data is, right? Is it which continent is it? So S3 was something, let's say, that we took under consideration seriously. We knew that we cannot refactor our application to benefit from service directly, but there was one, let's say, idea, one thing that we could use it to circumvent this issue, right? There is a really nice library, XTRF, which should, I think we should give you some more possibilities. So it's basically a file system in user space that lets you mount S3 and pretend it's actually a local file system. So if it comes to this solution architecture, we have a container holding JVM, our JBoss application server. There is data container, really nice abstraction layer provided by Docker, which benefits from a volume exposed by local Docker host that actually direct every single request to S3.
I think that it should be pointed. So regardless you want to go into the cloud or not, if your administrator is telling you that there is no more space on the file system for you, simply mount S3 remotely and you will have infinitive space for your application. So it's definitely something you can get.
Sounds great, but it turned out that our application has certain corner cases that, for instance, rely on a lot of stat operation. So, for instance, there is like 150 directories made consequently. If you use local file system, you won't even notice, right? That's let's say, a corner case that won't happen pretty often. But if it happened on S3, then we realized that it takes like 3 minutes actually for this particular operation to accomplish. Oh crap, that's totally not acceptable, right? If such operation takes 3 minutes, then it won't work for our customers. So we tried to find something different. We managed to let's say, overcome this problem a little bit. There's different service that from provided by Amazon EBS, maybe you have heard of it, that you can buy block devices as a service. Really nice idea. You can combine them, create logical volumes, for instance, and mount within EC2 this Amazon Cloud tier as local file system and expose. So we exposed this file system over SSH-FS. Yet another, let's say, hacker trick, and we did manage to decrease this duration to 50 seconds. Well, slightly better, but still not great.
Yeah, so it was the moment when we said, okay, we need to rewrite a little bit the application. It wasn't very difficult, so we simply limit the number of the directories that are created in one shot, and now the directories are created when they are really needed. So basically not a big change, probably not that important from a customer perspective, but for this movement it was quite crucial.
So what's in it for you? You simply need to understand how your application uses local file system, right? Can you actually take this approach or not? Depend on different case. Okay, let's move on. Second problem, SQL as a service. Let's say Postgresql as a service. We started with Amazon RDS, really cool piece of technology. You can click out your infrastructure, SQL infrastructure within seconds, like set up master and slave database really fast. However, the problem is performance in this case, right? So we built such infrastructure just for the sake of testing and started benchmarking it. This is really nice tool, pgbench. You can benefit to perform TCP kind of test, a stress test, in order to understand how many transactions per second can this kind of database infrastructure perform. And it worked as a charm as long as you stayed in Amazon, right? If you had a virtual machine that was hosted by EC2 and was accessing your SQL services from there, then you can come up with, let's say, reasonable numbers like more than 300 seconds. Absolute limit for XREF product is 200 seconds. That work more or less nice. But we insisted on being vendor agnostic, right? We wanted to have our worker node somewhere else, let's say in different part of the world. So we tried to call from Quebec, from Canada, let's say from a data center owned by OVH, to RDS service that was actually in West Virginia, pretty close. And then we realized that the results were kind of disappointing, like 14 transactions per second. That's let's say ridiculous. I mean, of course, it's up to you. What are your limits, right? You have to understand them in order to make such decision. But at this point, in our case, it was clear that was not acceptable. For fun, we even tried calling from Kraków to RDS in West Virginia over the ocean, 7 transactions per second. That's hilarious, right? Why is it hilarious? Because if we compare these numbers with what we can achieve in our cluster environment, our initial solution, where we have, let's say, full control over SQL Server and nodes, we are able to tune it up to 1,500 transactions per second. That's a lot, right? One may argue that it's actually kind of a ridiculous number, right? Because we are pushing limits too far. A lot of things happen in memory rather than on disk. That's true. But if it works, your customer are paying for it. Why not, right? So that's at this point, it was clear for us that we won't be able to benefit from database services, SQL services from the cloud. We have to build it on our own, right? But like this time, let's move on. etcd, that's really cool piece of software that we also put in our landscape of solutions for building this infrastructure. What do we need this for? Once you have, let's say, hundreds of JVMs, hundreds of containers, you need sort of inventory just to keep track of what is being launched where, right? You need to keep a registry of processes, port numbers, IP addresses, where it was started for, what kind of customer was it launched for, what kind of domain address is needed, and so on and so forth, right? So you need this kind of registry for storing your configuration. This registry needs to be available globally, right? Because you don't know which country your workers will boot. And you, of course, need this registry to be more or less fault tolerant, or at least to have higher availability. And etcd, it's a really cool piece of software. It's a key value store. It's a distributed database. You can scale it up to 9 nodes that can actually contain data. But if you need more, it's not a problem because you simply set up more nodes that work as a proxy services, right? So it simplifies design a lot because we can assume that there is always a single etcd container, etcd process available for local containers. So there are no differences between two particular nodes. That simplifies things a lot. etcd is written in Go. It's Docker ready, right? So setting it up takes literally minutes. So that's cool. It has a really nice feature called CAS. What is it about, right? If you're into NoSQL database, most likely you are familiar with this concept of conditional write, right? That it's not transactional system, right? But you need sort of a mechanism for mutual exclusion. So if one of the nodes is about to write data, let's say update some sort of a version, some sort of entity, whatever, it can be done only assuming that certain condition is met, right? So let's say I will override the states given that the previous state is that value, or I can update an entity given that the previous version of entity equals something, right? This will give you that led us to build so-called, let's say, autistic automation services. So how it works in our case, for instance, if you want to set up a container for a new customer, we put all necessary information in etcd. Like there is a list of let's say, those attributes that are required to set up a container. And automation services that are installed on every single node compete against each other in order to grab this order and set up container. This compare and swap, this conditional write mechanism assures that consistency is kept, right? The etcd solve mutual exclusion issue here. So really nice feature, helped us to save a lot of time.
I think that it should be like stress. So instead of command and conquer pattern, when the administrator or a script in the name of administrator asks a particular container to do something, we completely switch this idea. So the only thing the administrator does is provide a configuration, conf-d, and there are some nodes probably doing nothing that are interested in getting this configuration and start doing something important. Yeah, so they are responsible for taking this configuration and starting your services. Of course, there is a monitoring service we'll be talking about in a minute, but it gives you real flexibility because then you can run this container anywhere in the world, and then it will be able to pick up this configuration from conf, which is completely available all over the world.
Right. So we have this inventory global configuration database. That's great, but how do we actually benefit from this information? How does it happen that actually, let's say, port number is reflected in a proxy configuration? There's a really nice service, confd, that simply listens to etcd changes, and you can script several actions. Like for instance, if you perform a rollout, an update of a version for a particular customer. So what do? You shut down a single container, want to boot another one. Docker will do it for you, of course, but this new container will start being bound to different port number. So how do you, let's say, reload Nginx configuration in order to depict that information? Confd fit into that needs. It simply listen to etcd event, right? Because you need to update etcd just to tell the infrastructure that the new container from now on runs on different machine or on of different port number, and it sends proper signal to Nginx daemon just to reload configuration. So etcd plus confd, real powerful combination. So feel encouraged to find out more. Okay, let's move on because there are a lot of cool things. We have cool technologies that we used. Ansible. I'm pretty sure that some of you have heard of it. These two technologies, Docker and Ansible, that they overlap to some extent. Typical life cycle of a Docker image is that you start from a Docker file, which is basically a descriptor of the image, right? You put all the changes you need to apply it on the operating system in order to end up with a, let's say, image that can be reused or started on your infrastructure. However, this very first phase of composing, of developing Docker file might be kind of tedious, right? Because you have to rebuild it several times, understand if your changes are correct or not. If it comes to Docker, the development, that's kind of tedious. However, Ansible is slightly different, right? It lets you more or less do the same things, but you don't need any kind of infrastructure. You can invoke your Ansible playbook, which is basically a list of commands that can be applied on a system. You can invoke this Ansible on local machine or over SSH or some kind of other test machine. It also gives you a possibility to compose changes you have to apply on a let's say, bare operating system to behave as you preferred. So Ansible gives you also some let's say, some feature well known to, let's say, development world. You can decompose your script easily, right? In Docker, you may already know that there is only inheritance, right? You can reuse, let's say, your Docker files, Docker images over inheritance. Whereas in Ansible, you can decompose your long scripts into smaller pieces, test them separately. You have other cool things like, let's say, variables. So what is it basically is Ansible script preprocessing, right? You have some macros you can benefit from. So it's easier, right? It's easier to develop, let's say, a descriptor for your image for the system in Ansible rather than Docker file. So maybe let's combine these two things, right? So the way we are building our images for the infrastructure is basically to create a Docker file that calls Ansible, that invokes Ansible. That's kind of simple. You benefit from two worlds. I encourage you to have a look at this as well. Just one short information regarding Ansible used in different way, right? Because what we just saw was Ansible being used from Docker. However, you can benefit from Ansible for let's say, installing new boxes you have just bought, right? So now we are talking about the case when your infrastructure needs to grow. You need to buy new machines. So what you receive is basically either some sort of a credential, so login password or SSH private key for this new machine, and you want to install it and make sure it join your cluster, join your infrastructure quickly in an automated manner. So do it in Ansible, right? That's pretty easy. You execute certain playbook against new machine. It install all our automation services. It installs Docker, which is most important. It starts, let's say, those containers that should be running all the time. So that's kind of very nice usage. Let's move on because we don't have much time. Monitoring. Of course, you need one, right? You're hosting very large infrastructure. This is what we did, let's say a few hundred processes. You need to understand whether they are up and running, whether there's something wrong with them, whether they're consuming too much resources. You need some sort of system, right, that will give you that information. Once you have it, then you can think about some automation actions regarding, let's say, recovery. Okay, one Docker host went down, right, because something happened. You need to set up another one in a different place, but which containers were there, right? You need a certain level of automation in this area. So if it comes to monitoring, there's a question: shall we build it on our own, or maybe we can buy it, right? So we explored some, let's say, known technologies like Nagios, Munin, for instance, Amazon CloudWatch. There are other options, but then we realized that we can actually buy something that is ready. Datadog. Really nice feature. It costs like $15 per Docker host. All it takes is to install a Datadog agent on your Docker host, and all metrics, all that data will be streamed into someone else's infrastructure that will give you this really nice dashboard in return. So something you can set up very quickly. Don't spend much time on it. You have useful data in return. Where do you go from here? It's actually up to you. So let's move on. Maybe let me skip Amazon says for sending emails, but DNS Simple. Also really cool piece of software we have managed to benefit from. So if you have an infrastructure that it's not stale, right? It has to change from time to time. It's kind of important how much will it take for domain names to propagate all over the world. Right? If you perform a certain change in DNS, it takes sometimes like hours actually to be visible on the other side of the world. However, there's this service DNS Simple that actually it is a service. What they guarantee is TTL equal to 0, which means those changes will be propagated quickly, right, with zero downtime. So they have really powerful DNS servers. But what's more important, all changes can be performed over REST web service, right? If you have some automation logic that requires DNS change, DNS Simple work well in our case. So
it is possible to switch the bunch of customers from one data center to the other data center like in a few seconds. Of course, they will lose their sessions, but the system will be available quite soon.
Okay, so let's sum it up and try and have a look how our architecture look like. So it may look convoluted, but it's not.
It's a little bit complex. Yeah.
Okay, so we install host in pairs, right? It is for the sake of Postgres replication, database replication, right? So we call them extension units. On each Docker host contains as much containers as possible. That actually depends underlying hardware, right? We have different type of servers. For instance, it pays off if you buy, let's say, big machines like 192 megabytes of RAM, for instance. You may also have different machines with, let's say, better storage for let's say, more demanding customers, right? So it does not need to be same. It's up to Docker host how much containers can it actually take. Each Docker host contain this etcd process, which join global cluster. That's kind of an infrastructure service. Each Docker host has its own proxy server and of course automation logic. every pair keeps state as much as possible, because we have excluded database, keeps state in cloud services. So we either put it in Amazon S3 or Amazon EBS, and benefit from those other cloud services we had already discussed. So if you want to scale up, we can simply add more and more extension units. Geographic location is not that important.
Yeah.
Okay.
At the end of the day, it's all about money. So if you want to have your CFO, CTO, and other C guys to commit to this idea of switching to Docker, you need to show them the money. So where will we be paying less? And you cannot say that we will switch to cloud and pay 10 times more or 5 times more than we are paying today. No, it's something that you have to bear in mind, that at the end of the day, the money rules. And what we managed to achieve is like the final price of the infrastructure is less that we have on the bare metal, which was quite challenging. And moreover, we also can benefit from all the others like non-functional requirements in terms of scalability, security, high availability, and all this cool stuff that you guys enjoy, and our C-level guys usually do not understand.
Right. So yeah, the money shows that it makes sense. Let's have a look at final slides. Regarding other approaches, right? Because we did something on our own. So the question is, does it make sense given there are so many projects, so many other technologies that are on the market, right? Why didn't you use Kubernetes, one may ask? Well, at the moment of writing the software, we needed something simple. Alternatives were kind of either alpha or kind of complicated, so this is what we didn't go. But the conclusion is that you have to be up to date regarding changes, right? Docker Swarm might be a tempting alternative to use it to build it into our infrastructure. Why not, right? It's actually the world of containers has just exploded, right? This technology is emerging, so a lot may happen. And we can also see it from let's say technology adoption perspective, right? Because there are certain features that simply were outdated. We started from for instance Docker links. Cool feature for composing Docker relationship. Now it's obsolete, right? You should be using, let's say, Docker networks. We initially started with Fig for orchestrating containers. Now it was, let's say, overtaken by Docker. Now it's called Composer. Almost the same, but let's say slightly incompatible. So you have to keep that in mind, that that's new technology. You can easily stay behind, and you have to keep up the pace. And final thoughts, right? It's not that easy actually to find people that have some experience, let's say, in Java, in Python scripting, in sysadmin, right? You need, let's say, pretty broad landscape of skills. So that's kind of challenge. Okay.
We mentioned money. There is one important element we have to add. All these works were possible because we get the grant, so they were partially financed by European Union. It gives us a space for all these experiments that we share with you, because it's not the only cost that you have to pay for the infrastructure, but also have to pay for the people that experimented, that finally built this, and it's also quite expensive. So basically, we would like to thank you for your time. We're open for a question. You can have a mic, I guess, and ask now or after the presentation. We are here to clarify something. Yeah.
Did you have any problems with the Docker stability itself?
You mean stability if it crashed?
Yeah, with the Docker daemon.
Well, there were several issues, for instance, regarding same containers being run on same, let's say, port. So there were some issues that, like, Docker is not bug-free. That's true. But we didn't, let's say, face segmentation fault. If you this is what you ask.
Yeah, but we finally get to the moment we have done more than 200 instances that are operating. Quite
we believe
smoothly.
it's stable solution nowadays.
Okay, and do you apply Docker on the virtual machines or on bare metal?
We benefit from let's say, commodity hardware. So we buy, let's say, from So You Start service. So they actually give you bare metal, but virtual machine is the same, but it's all about the price, actually, right? So virtual machines are sold, built by hours, whereas let's say bare metal is something you pay upfront. So that's a different pricing model. Yeah.
Did you consider a solution like Mesos or DCOS?
It's different approaches, right? Why not? There are so many other options. As I said, this world of containers explodes. So the question is, why didn't you take other approach? Maybe we were simply not aware of it, that's there. Maybe it was immature.
Yeah, the decision was like more than 1.5 years ago.
Yeah.
So basically, Docker was the only reasonable choice. Now also Google offers this. Also Amazon offers Docker hosting. So basically, it looks very promising. So maybe we finally switch from our own bare hardware to the Docker services somewhere in the cloud.
Cool. Any other questions? Yeah.
How do you handle security updates? For example, in the underlying Docker layers, or in your software, or in JBoss. How do you handle this? Do you rebuild? How often?
Well, security is a kind of complex problem itself, right? So we have to take care about transport security, right? Because we don't have, let's say, single collocated data center that's, let's say, externalized into single VPC. We have the way it looks like we have a lot of nodes that are exposed globally, right? So we have to make sure that the connection between is secured. For instance, Postgresql replication, right? It has to go over secured connection. So that there are several approaches like tunneling, SSL. That's what we simply have to rely on. If it comes to features, for instance, if we keep storage in S3, right? That also goes over secure channel. But that's the question: can you actually trust, right, the other counterparty? That's more challenging if it comes to security.
I thought mainly the Docker image itself. You build Docker image, and some of the layer in it has vulnerability.
That's a cool question, because the concept of Docker is actually to reuse images that are, let's say, exposed by someone, right? Nowadays, by guys that perform their operation itself. So the question is actually, can you trust the Docker registry you're pulling images from? So we built our own one, right? So we believe that those initial images, like let's say Debian Jessie, it's worth trusty, but all the changes that we applied, then we compile it and put it into our own registry. So we consider our own registry most trustworthy than those exposed globally.
I think that we definitely need to finish. So thank you for your time. If you have another question, we can handle it after the session. Thank you.
Enjoy the
Have a good
session.
conference.
Yeah.